everyone, welcome to EduShop. So today we will discuss a very important concept, that is the concept of infinite sequences. So what are infinite sequences? First we will learn them and then we will understand some very important properties of sequence. So what is a sequence in mathematics? In mathematics, a sequence is something which is enumerated. Enumerated means there is numbering which is being done. Okay. So if I say an is a sequence, this is the terminology. I write an inside curly brackets and n belonging to n. It means that the elements of the sequence are a1, comma, a2, comma, a3, and so on. Because the set of natural numbers is infinite, so my index set is an infinite set. So this is the indexed set, which is my sequence. Now, in case of a sequence, ordering is very important. Okay, what does it mean? It means that I cannot shuffle the elements of this sequence. A1 has the first place, A2 has the second place, A3 has the third place, and so on. So that is what a sequence. So what is a sequence? It is an enumerated or it is a list of objects where the position of the objects is fixed. I cannot shuffle the places of the objects. So definitely in mathematics, we are interested in sequence of real numbers. We really want to know the behavior of this sequence because we don't know what is going to happen as n becomes larger and larger. So let us try to take some examples. Example 1, consider the sequence an is equal to n. That is, the sequence is 1, 2, 3, 4, 5, and so on. So you can see that as n increases, an also increases. So as n is increasing, an is also increasing, and n is increasing without bounds because I am on the set of real numbers. So we say that an goes to infinity as n goes to infinity, or we write limit n tending to infinity, an equals to infinity. It means that my sequence is going towards infinity when n is becoming very large. It means that a particular element will become larger and larger as n becomes larger and larger. Okay, now let us look at another example. Example number 2, consider an equals to 1 upon n. Again, n belongs to n. So my sequence will be 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. So what do you see here? The first element is 1, the second is half, which is less than 1. The third is 1 by 3, which is less than 1 by 2, and so on. So what is happening? As n is increasing, an is decreasing. You can clearly see that. So now, is there a particular point beyond which an will not go? So you can see that n is a natural number. So n is positive. So an is equal to 1 upon l will be positive for n belonging to n. But we are becoming less and less positive. So that means limit n tending to infinity an will be equal to 0. You can see that there is no term in an which is 0, but it is approaching towards 0. So limit may or may not be attained by the sequence. Okay, so you can see if you want to write a upon 1000, it is 1 upon 1000, which is 0.001. So if you want to write a of 10,000, it is 0.0001. If you want to write a of 1 lakh, that is the 1 lakh term, so it is 0.00001. So you can see that an is becoming smaller and smaller, tending towards 0, but it is not becoming 0. But you know, it is like you are dividing 1 by such a big number that eventually an is going to turn towards 0. Okay, so here we say that limit n tending to infinity an is equal to 0. Now let us look at a third example. So third example is an is equal to minus 1 power n. So it is minus 1, 1, minus 1, 1, -1, 1, and so on. So you can see that if I talk about limit n tending to infinity an, so as n is becoming larger and larger, an is not going towards a particular number. It is oscillating between -1 and 1. So oscillating means going from -1 to 1. If n is odd, I get -1. If n is even, I get +1. So no matter how big my n is, an will either be -1 or +1, but we are not going toward a definite number. So we will say that limit n tending to infinity, an does not exist, or we say that an is an oscillatory sequence. So now is the time of to introduce types of sequences in terms of their limit. Okay, so there are three types of sequences. One is called a convergent sequence. One is called a divergent sequence. And one is called an oscillatory sequence. Okay. So what is a convergent sequence? A convergent sequence is the sequence an where limit an is equal to L, where L is a finite real number. For example, +1, -2, +3, etc. What is a divergent sequence? When limit n tending to infinity, an will either be plus infinity or it will be minus infinity. So these two types of cases are the sequences which are called divergent sequence. Oscillatory sequence is the one where an oscillates between finite numbers. Example, an is equal to -1, 1, -1, 1, and so on. Another example you can create 0, 2, 0, 2, 0, 2, and so on. You can also have a situation like this 0, 1, 2, 0, 1, 2, 0, 1, 2, and so on. So you can easily see that it looks like that, oh wow, my sequence is going towards 0, it is going towards 1, it is going towards 2. So I might have a limit, but that is the catch. It is going towards three different numbers. So it is oscillating between three different numbers. It is not going towards a particular number. So these kind of sequences are oscillatory sequence. So what is a sequence? It is an ordered structure of numbers where enumeration is very, very important. We are able to count the elements. Also, we are able to order the elements. Then we have defined three kinds of sequences in terms of limits. So if the limit is finite, we say that the sequence is a convergent sequence. If the limit is plus infinity or minus infinity, we say that the sequence is divergent sequence. And if the sequence looks like that it is oscillating between finite number of values. Now, finite values can be 1. Finite values can be 2, not 1. If it is 1, if it is going to converge. So 2 values, 3 values, 30 values, but finite values, 300 values. So it might happen that first 300 values are same, then they are repeated after to account of 301 to 600 and so on. That kind of sequence is also an oscillatory sequence. So in terms of limits, there are three types of sequences: convergent sequence, divergent sequence, and oscillatory sequences. Thank you very much. In the next class, we will do how to define convergent sequences, divergent sequences, and oscillatory sequences in terms of epsilon delta conditions. See you in the next class.